Okay, everybody, so what are trigonometric ratios? Well, our trigonometric ratios we know are our sine, our cos, our tan, maybe our cos h, sine h. You may also have seen the same expressions soc, car, and toa up here. What they relate to are sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Well, all these mysterious odd words are sine, cos, and tan are essentially telling us, or they're a mapping of an angle theta to a ratio between two sides of a right angle triangle. So let me explain. If we look over to our right angle triangle on the right here, we can see we have an angle theta in the corner, and we have our corresponding opposite, adjacent, and hypotenuse sides of the triangle. So all sine, cos, and tan are is telling us that if I have an angle theta in here, then tan of this angle is going to be the ratio of the length of this side, my opposite side, over my adjacent side here. And if we were to look at an example of this, so one of our beautiful triangles, we call them, seen here, we can see that if I was looking at angle 30 in the bottom right corner here, then cos of 30 degrees maps my adjacent side, root 3, to my hypotenuse. So cos of 30 degrees is equal to my adjacent side, root 3, over my hypotenuse of the triangle, on 2. Similarly, sine of 30 degrees, well, that maps 30 degrees to my opposite over my hypotenuse. So 1 over 2. So you can see sine of an angle and cos of an angle are just mapping to the length of two sides of a triangle. And why these are so significant and why we see them around so much is that for any triangle with 30 degrees and 60 degrees inside, then the ratio between the opposite and adjacent sides is going to be the same no matter how big or small this triangle is. If we look at another example of a triangle where I've scaled the above triangle up by 2 on every side, if we look at cos of 30 degrees again, well, that's going to be our adjacent side over our hypotenuse. So cos of 30 degrees for our new triangle is going to be adjacent to root 3 over 4, which this is the same as root 3 on 2 if we cancel the common factor of 2. So we can see that it doesn't matter how big this triangle is, if the angle inside is the same, then the ratio between the adjacent and hypotenuse side is always going to be the same. And this becomes a super handy piece of information in all sorts of engineering applications. Now, what about the unit circle? Why do we see this attached to sine and cos all of the time? Well, we all know our unit circle is a circle with radius 1. Now, on our xy plane, this point here is some coordinate x and y. So it's some amount x across here and some amount high y, like that. And we can see if we were to draw in those lines, then what we can form is a right angle triangle, where this angle in here could be theta. So if we were to then look at our ratios of this right angle triangle, well, what's sine of theta? Well, that's our opposite side, so y over our hypotenuse, which we're on the unit circle, so our hypotenuse is 1. So it's essentially the amount up we are over 1. Well, this is the same as just writing sine theta is equal to how high on the unit circle we are. So y, it's our y coordinate here. Well, what about cos theta? Well, cos theta, that's equal to our adjacent over our hypotenuse. So our adjacent is x over our hypotenuse, which is 1. So that will be x on 1. So essentially, cos theta gives us our x coordinate on the unit circle here. So now what would happen if we were to trace around our unit circle and observe what our x and y coordinates were doing. Well, let's look at what our x coordinate is doing first. So what I'm going to do is draw a graph of our distance in the x direction versus our angle theta as we move around the unit circle. So just as a reminder, we're going to measure theta from the x-axis like that, and it's going to increase as we move counterclockwise around the unit circle. So as I move up this axis here, what I'm going to be doing is moving around the unit circle like this. And I'm also just going to draw on some key values of theta. So when we're at the starting point here, we're at 0 degrees. As we come up to the y-axis, in line with the y-axis, we're at 90 degrees, then 180 degrees, 270 at the negative y-axis, and then back around to the start at 360 degrees. Awesome, so let's get started. If we start at theta equals 0, well, what's our x component? How far along on the x-axis are we? This is a circle of radius 1, so our distance along the x must be 1 at theta equals 0. So when theta is 0, 0, we're at x equals 1. So we're up here. Now what happens as we move further up the unit circle? So we're here for a bigger value of theta. Well, if we map down to our x-axis and measure how far along we are, we can see we're not as far along as we were before. So that means our value of x is going to be coming down as we move around the unit circle. As we make it to theta equals 90 degrees, well, let's measure how far along the x-axis we are. We can see we're at 0. We're not along the x-axis at all. So when theta equals 0, well, when theta equals 90, we're at 0. What happens as we come past 90 degrees? About 130. Well, now we're in the negative x region. This here is the negative x region. This here is the negative y region. Well, let's measure across. Well, we are gradually growing as we come along here from 0. So our graph is going to look like this, gradually growing in the negative direction. And what happens as we come into 180 degrees? Now we have a radius of 1 again. Or negative 1, on the x-axis. And then as we come down into the negative y region, well, our x is starting to shrink again. So we're coming back up. And what we're going to have form is this sinusoidal graph. This is where it comes from. That should not go past 1. And we can see that this is in the form of what we call a cosine graph, or what cos theta looks like. Now, what would happen if we were to trace the y coordinate as we went around the unit circle? So let's start back at theta equals 0. Well, how far in the y direction are we at this point? Well, none. Our y coordinate is 0. We're not going up any. We're flat along the x-axis. So sine theta, or our y coordinate, is going to start at 0. As we trace up and along in the positive theta direction, remembering theta is going this way, we can see the distance we're going up along the y-axis is constantly increasing. So, as we move along in the theta direction, our y-coordinate is going to be increasing. Then, once we get to theta equals 90, we can see we're going to be at our maximum, y equals 1. As we come back around in the negative x region, then our y-coordinate, well, it's starting to go back down, isn't it? I'm just going to quickly add in the other theta measurements here as well. 180, 270 degrees, and 360 degrees, like that. So if we're looking at our y-axis coming past 90 degrees, so we're in this region here, then we're going to be coming back down like this. And as we come all the way down, our y value is constantly decreasing, constantly decreasing. Once we get to 180 degrees, we're at 0 again. So we're at 0. Then as we come back into the negative y region, and our y value is going to become negative, it's going to come down until we're at 270 degrees, and we're at -1. And then finally back around to 360, where it becomes 0 again. So we can see that this is actually where our cos and sine graphs come from. It's tracing around the unit circle and looking at what our x and y values are doing. And that in itself maps back to a triangle, a right angle triangle like that, as any point along here is a right angle triangle if we look at the x and y coordinates, remembering back to the derivation at the start on the unit circle. So I hope that gave a bit of insight into trigonometric ratios, what they are, some purpose they might have, and also into those elusive sine and cosine graphs. In the next few videos, we'll be going into how to find exact values from the unit circle and other useful implementations of trigonometric ratios. So I hope you guys enjoyed. Please let me know if you have any questions.